Then, as I have already referred that the compact obtained after this process is known as the green compact, and the strength of this green compact is known as the green strength. So, what is green strength? It is the mechanical strength of a green compact, that is the unsintered powder metallurgy compact. And what idea it gives you? It determines the ability of a green compact to maintain its size and shape during the handling prior to the sintering. So basically, suppose if the green strength is very less, and then if you have to transfer this compacted part to the sintering process, sintering stage. So if it doesn't not have any required strength, so it can easily be broken into pieces while transferring from one place to another place. And this green strength, how you can increase this green strength? So this strength is increased or promoted by increasing the particle surface roughness. And due to this particle surface roughness, you have more sites, or you have more sites for the mechanical interlocking and cold welding to take place easily. And then you can also increase this green strength by increasing the powder surface area, and this can easily be achieved by increasing the irregularity or by reducing the particle size. So if you reduce the particle size, or if you increase the irregularity in the particles, then it will result in the increased powder surface area, which will eventually increase the green strength in this particular stage. How you can calculate this green strength? So basically, this stress is calculated from your simple flexural formula, and this is the stress which is required to break the specimen. So if you see there, the particular size of the specified for a green strength test specimen under this transfer band test load is 12.7 into 31.7 into 6.35 mm is the size of this particular specimen. And you can see there is a universal testing machine, and below it at the base there is a special fixture which has some simply supported or pin type of rulers, which is used to support the green compact. And from the and in the center, with the help of a punch, you apply the pressure till it breaks. And basically you calculate the maximum deformation, or the deformation up to its breakage. And from this formula, which is equal to the green strength is equal to 3 into P into L upon 2 WT square. It gives you the green strength in Newton per millimeter square or in MPa. So what is P? P is the breaking load, and which is in the Newton, and L is the distance between the supporting rod. So basically, these are your supporting rods, and L is the distance between the supporting rod, and T is the specimen thickness, and W is the width of the specimen. Through this simple formula, you can easily calculate the green strength of your material, and it also gives you about the effectiveness of your compaction, that how much you have compacted your product. So this green strength is also gives you a direct idea about that you are close to the required specification, and how much you have achieved the densification. It gives you the idea about that thing. Then in the compaction stage, so we will discuss some problems which you encounter during the compaction step. So as you can see from this figure, there is a die cavity, and then you have filled this die cavity with the powder material, and from the top of it you are applying the compaction pressure with the help of a punch. So if you see here that these closely spaced line, these represent the variation in the microstructure. You can see the variation in the density. So the powder which is very close to the punch surface, it acquires the required density, while the powder which is below this layer, and gradually when you reach at the bottom, there is a large density difference. So why this is happening? Because as the compaction force will not travel all along the depth of the part, as due to this, as a result, the powder near the bottom of the die cavity is little this is basically little compacted, and for basically for the thin parts. So if your thickness is very less, suppose if your thickness is close to 5 or up to 6 or 10 maximum up to 10 then you can easily you can achieve the required amount of densification through a single punch. But if your part is of high thickness, then how you can achieve this densification? So required densification can be achieved with a slight change in the compaction arrangement. And how it is happening there? So for this purpose, you require two punches, from one punch from the top side and another punch is from the bottom side. And then you can see here that the you will have a somewhat uniform density in the material. So next is the condition when you have a step part, when you have some step in your part. So in while pressing the part, you can see you can easily observe that this portion, this darker portion will have higher density as compared to this left hand portion. This right hand portion will have higher density as compared to the left hand portion. So why this is happening here? Because first of all, this particular portion is closer to the die, this punch surface, as well as the area is very less. So here the compaction pressure will automatically will be more as compared to this area. So you will have again you will have the variation in the variation in the density in the part. And how you can resolve this problem? By using basically this double punch arrangement or basically triple punch arrangement. So in this way you can control the density inside the your material powder metallurgy compact. So these are some of the problems which you can easily face while doing the compaction in this powder metallurgy process. So up to here, do you have any confusion?
Hello.
Is it clear to you? Is there any confusion?
The ग्रीन स्ट्रेंथ और टैप डेंसिटी में कोई रिलेशन बना सकते हैं? जैसे टैप डेंसिटी इंक्रीज होने से ग्रीन स्ट्रेंथ भी इंक्रीज रहे हमारी.
टैप डेंसिटी से ग्रीन डेंसिटी. Your question, I don't understand your question. What you are asking?
By increasing.
Is there any relation between the tap density and the green density?
Yes.
Basically, tap density, what is tap density? We have already discussed that this is the tap density that which is achieved by tapping the powder inside the some, if there is some beaker is there and you have filled your powder and then you have increased the you have applied the tapping to this beaker, then what will happen? The vibration will cause the movement of the particles to fit inside each other easily. The the voids between the big particles, it will be easily filled by the small particles. So in this way, your tap density, your you can say your apparent density will increase on tapping the powder particles. Okay, and this is the green you can say green strength. So green strength is the strength which is obtained after the material is compacted in the die cavity, but it is prior to the sintering stage. Okay. So suppose if there is some mechanism of vibrating the die cavity, or some vibration is given to the your punching while doing the compaction pressure, definitely it will have some effect on the green strength.
It means by tap density, somewhat green strength will be promoted.
Yes, tap density, but how? But it is very difficult to achieve the tapping in the compaction stage. Okay, because
Okay.
you have the big size press, and all the fixtures are rigidly supported on the machine. And also it is not good to basically to vibrate the fixture and your tool inside the die cavity or in the machine, because it will lead to the wear and tear of the parts. So, if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.